Welcome to Study Loop.
Okay, this is Chapter 11, Section Problem 84. The question is, the vapor pressure of CCl3F at 300 K is 856 torr. If 11.5 grams of CCl3F is enclosed in a 1 liter container, is any liquid present? If so, what's the mass of the liquid? So when I did this first, I thought, okay, well, what if this were all gas? If all 11.5 grams of the CCl3F were a gas, what would the pressure there be? So to do this, I utilized the ideal gas law. So PV is equal to nRT. If you rearrange that to get the pressure is going to be equal to moles times the gas constant times temperature divided by the volume. And if I plugged all that in, so first I converted the grams to moles, and then multiplied by the gas constant, which, leaving it in torr, liters torr per mole Kelvin, is 62.364, multiplied by the temperature divided by the volume. I got 1566.4 torr, and that is more than the pressure by the vapor pressure. So clearly some of this is going to be left over as a liquid. So we could have just started with this calculation down here. So to calculate how many moles of gas is actually able to be formed, we just rearrange the ideal gas a little bit differently. So to calculate the number of moles possible, just rearrange it. So N is going to be equal to PV over RT, which is the number of moles of gas. So using the vapor pressure in this part of the equation, so pressure is 856 torr times 1 liter divided by, again, that gas constant times the temperature, so 62.364 liter torr per mole K times 300 K. That should give you 0.0549 moles of gas that are able to be formed, or that are, formed due to that vapor pressure. And then you can convert that to grams of that gas by multiplying it by the molecular weight. Again, moles times grams per mole is going to be equal to grams. So 0.0549 moles of CCl3F times the molecular weight, which is 137.36, is 7.54 grams of that gas. And then if you subtract that by the total mass provided, which is 11.5 grams, that gives you 3.96 grams of the liquid remaining. So to solve this, you needed to pick out a gas constant. It's easier if you just leave, you look at the problem, see what kind of units they give you in pressure, and then you can just use that gas constant. So again, I use liters torr per moles per K, and you need the molecular weight. But other than that, you just plug it into the ideal gas law and subtract that gas that you were able to be formed by the total mass, and there you go. Okay, well, that's how you do this question, and good luck.